So as we are now doing the 7th edition, we started to realize that there is a lot of value when looking back at what we said a few years ago and tracking. You can see through John talks, tracking how the wine has evolved, either as a result of the microbiological responses, but also as a result on how the polymeric anthocyanin have stabilized the wine color or not, how the tannin perception on the sensorial level has evolved. And we thought that it could be very interesting to have a look at those results in the past with a pair of fresh eyes. So we started to realize that, yes, interestingly, in 2011, we were in Napa. Some of the winemakers that were doing the panelists are still working in Napa, so we invited them back today. And we are going to have on stage with us Helen Keplinger, Daniel Baron, and Roger Boulton, who had spoken in 2011. So 5 years after their opinion on the vintage, it will be very interesting to see how the wine has evolved. So it's my pleasure to invite you on stage, Daniel, Helen, and Roger. And in order, and last minute guest, we have Marc Devere, who very kindly accepted to join us. So I know it's a last minute, so it's a bit challenging for him, but we thought it would be very interesting to have a trained sommelier giving us the feedback from the ground, from the end consumer, how 2011 wine profile is actually tasting. So really the idea here is to combine a scientific approach with a hand-on practical approach with a more hedonistic, more sensorial-based approach. And in order to set up and framing this discussion, I'm just going to wrap up a few of the results we had in 11 and in 16, just to give some context and hopefully start the discussion. So first of all, as we do usually, we looked at rain. So Greg Jones showed us what kind of rain we are likely to expect for the start of the season currently ongoing. But remember 2011 versus 2016. We had higher rain in 2011, but really up until the middle of February, we were looking at similar total amount. It's just that the equivalent of the 250 millimeter of rain we got in April in 2016 got delivered to us in February 2011. But the big picture is there. You see relatively comparable amount of water. So we started with a root reservoir full. Looking at the spring rain amount, well, this is the rain I was mentioning. You see that 2016 equilibrated with 2011 before bud break, but on top of that, we had even more rain in 2011 during the spring. So what does that mean? Well, it means that both years had the footprint of no water deficit during leaf area development. So remember period 2 and 3 as we discussed. So we know it has consequences on nitrogen uptake, it has consequences on setting up the yield, it has consequences on delaying sugar and delaying color. First fall rain, that's important, and it's also in the mindset of talking about lacase, since Professor Boulton had done a very in-depth talk in 2011 on what kind of residual lacase activity we could expect maybe 3, 4, 5 years down the road. Well, that bears the footprint of the first fall rain. You see that in 11, October 3rd, we started having our first rain, and around the total month of October, we had 130 millimeter. And in 16, we started much later, by October 14. Thermal time from March 1st up until harvest. What do we see here? We see that the green line 2011 is below 2016. We know that heat accumulation drives the speed at which sugar accumulates, at which acid degrades, and ultimately at which color peaks. So we are going to look at two different things. We can either look at those two different thermal time profile by setting up a threshold. Remember, period 4, I was saying that peak of sugar loading is met around 1300 growing degree days. Peak of color is either jointed or slightly decoupled and happening later. That's why I used the mark 1400 growing degree days. And this mark was reached early September in 16, was reached early October in 11. So the question is, how does that impact winemaker decision as far as harvest go? Or you could look at the other way around, setting up one date, so for instance early October, and acknowledge the fact that in 2016 you were maturing 200 growing degree days ahead of 2011. So fortunately, thanks to the courtesy of ETS, we are going to look at the chemistry of this data. But before we go there, I simply wanted to give a last look at the light regime distribution to make sure that we were going to compare apple to apple. And doing the same thing that I had done during the morning session, looking at light cumulated during bloom time up until 1300 growing degree days, you see that we have similar level of light supply. So if we try to articulate that with how much it stimulates and upregulates anthocyanins, we know we are comparing years that are similar from a light regime standpoint. So that brings the summary of the seasonal traits in 11 and 16. The years were both showing low water deficit, and the light regime was comparable both years. What was different is the higher water supply in 11, which we know means even further delay in sugar and higher berry weight, and slower heat accumulation as a consequence of cloud. So, again, to keep things in perspective, we were predicting a higher berry weight, and indeed, you see that not only the berry weight was roughly, on average, 20% higher, but was also reached later. Those are direct footprints of the seasonal traits of those 2 years. So delayed berry weight gain in 2011. Onset of sugar loading. So the onset is the moment in time when the fruit starts to switch from being a vegetative organ to a reproductive organ. So what I'm looking at is when we start to accumulate a similar amount of sugar, and you see that really we were at 100 milligrams of sugar per berry, roughly 30 days before. So we know that's also, again, a carryover effect of thermal time being delayed in 11. And that translated in the bricks, obviously. So the fruit traits, well, the differences is that the delayed sugar loading in 2011 was 30 days behind. So as expected, it delayed color accumulation. And higher peak berry weight will probably be related to some dilution effect if we look at polyphenols. So those are my last 3 slides. If we look, based on the data we got from ETS, at the tannins levels observed in 4 different vineyards, you can see that the concentration expressed here in a catechin equivalent is on average higher, but not markedly higher in 16, maybe a little bit more pronounced in vineyard B and C compared to A and D. So what are the differences between those 4 vineyards? Well, it's harvest date. In vineyard A and D, we actually look at the same thermal time cumulated at harvest, which means that 2011 was harvested 1 month later than 2016. And what do we observe? We observe that in 2016, total anthocyanin was higher when the harvest window was positioned according to equal thermal time accumulation. We could also hypothesize that due to the larger berry size in 2011, there might have been a dilution effect to explain the lowering of total anthocyanin. However, interestingly, in 2011, having harvested not according to the same civil date but of the calendar, but according to GDD, led to a higher amount of polymeric anthocyanin. We can hypothesize that lower temperature during the color accumulation helped a better color incorporation, leading to a higher amount of polymeric anthocyanin. If we look at the other way around, when actually it's the calendar date that was kept the same in vineyard B and C, you can see that actually it's the opposite. where we had, despite the dilution effect, a higher concentration of anthocyanin or a similar concentration of anthocyanin. But if we look back with what we've observed earlier during the morning session, it might simply be due to the fact that when the fruit was harvested, we were still on the rise in terms of color accumulation or at the peak, whereas we were maybe already on the decline in 2016. What is a bit difficult to understand is why we have more polymeric anthocyanin in 2016. Well, maybe we could hypothesize that because the harvest date was 200 growing degree days later in 16, well, we had more time for color incorporation into tannins. This is a hypothesis. This is in part what our first PhD student was discussing, but this is just food for thought. I don't know for sure if this was happening, but we have a panel to discuss those points. Why did we have more polymeric anthocyanin in 2011 when harvest day was on the same date based on the civil calendar? So with that, I just summarized that we had a higher tannin content in 16, maybe the footprint of a slightly higher level of water deficit. If harvest day is at the same growing degree date, then we have a higher color incorporation in 11. If harvest day is on the same day of the year, we have a lower color incorporation in 11. So now the question that I'd like to ask our panel to start the discussion is, what is your take on, what is your practical experience on harvest date? Delayed or not delayed with respect to growing degree days? Is this actually a relevant standpoint? What is the effect of delaying harvest date on aroma degradation? We've talked a lot about polyphenols, but we haven't so much insisted on what Ponce in the Vintage Report 2012 shared with us. He spoke about those compounds that bear the footprint of high temperature exposure prior to harvest and that have a carryover effect way until after bottling. Then botrytis pressure. Roger Boulton had expressed his concern regarding residual lactase activity. How does that affect the oxygenation of the wine even after bottling? We discussed that in 2011. And last, with the talk of Andrei, we understood how different species of oak were actually contributing more or less to the sweetness characteristic of the wine. So how did your barrel making decision affected the aging potential of the wine? Those are questions that I'd love for us to brainstorm and to hear from our panelists, maybe a good